My name is Andy Heidelberg. I'm a solar system ambassador based in Boise, Idaho. I'm going to talk to you guys about the moon today. And there you see it on your screen. So first things first, I am not an astronaut. I am what's called a solar system ambassador. So I'm a space enthusiast. I live in Boise just like you guys. And what we do is we go through schools and libraries and present information to the general public on latest discoveries and missions. My email's there at the bottom, so if you want to have your teacher contact me, maybe for next year, we can go visit you in your classroom. So quick agenda, I'm going to talk about what we know about the moon, how we got to the moon. I'm mostly going to talk about the American activity. There are several other countries that have landed uncrewed missions on the moon. And then, are we going to go back to the moon anytime soon? Before we talk about the moon, instead of playing around online, if you want to look at some space sites, if you're interested in that, information on the solar system, if you want to draw your own rover or planet, comic books about space science and earth science, and various pictures. If you're a little older, same thing, more information on the solar system, on various missions that are going on now, on all the robots that are out there in the solar system, some graphic novels about space, and discoveries about the Hubble telescopes made. And then if you want to play around, you can go online and download the NASA Selfies app, take a picture. It'll put the picture in an astronaut suit somewhere in the universe, and you can pick your backgrounds. So if you've ever wanted an opportunity to send your brother or your sister, or your dog or your cat or your librarian into outer space, here's your chance. One thing on the links that I forgot to mention is a lot of those are about space as opposed to the moon specifically. If you go into the library online catalog and just type in moon, you'll find hundreds of books you can learn more about the moon. I'm not listing any books because if I list one and someone takes it out, before you get there, you can't get it. But there are lots of books out there, so the library is not going to run out. So we'll start with something easy. So why does the moon look different at different times? So here's the Earth, and the moon orbits around the Earth. And here's the sun. So sometimes the moon's between the Earth and the sun, so we only see the back side of the moon. That's no sunlight's on getting there. So we call that a new moon. There's no moon. Sometimes the moon's fully being reflected by the sun, and we call that a full moon, a half moon. So every month, roughly, we'll go through no moon, getting a little more, half a moon, a full moon, back down to half a moon, and the dark side. And then no moon again. We only see one side of the moon. The moon's tidally locked, so we always see the same face of the moon. Is there a dark side of the moon? No, there isn't. It's dark to us, but that side still receives sunlight, just not when we're looking at it. And here's the phases of the moon, a little more detail. So here's our new moon, the young moon, a sliver to the right, getting bigger, halfway lit, getting bigger, full moon, and then the same thing in reverse. So if you see a sliver to the left, it's called an old moon. We're about to have a new moon. You see a sliver on the right, it's the young moon. It's going to start getting bigger. And here's the moon. So the view on the left is what you see all the time. The moon's tidally locked. You always see the same side of the moon. And the moon on the picture on the right is the other side of the moon, the far side of the moon. And one of the things you'll notice is the far side of the moon has a lot more craters on it than the near side. The near side has these large areas where no craters have hit. So why are there more craters on the far side? If you think about it, it makes a lot of sense. These are all meteors, and then crashing into the moon as meteorites coming from far out in the solar system. So it's more likely to hit the side of the moon facing out the outer solar system than facing the Earth. So the moon does a really good job protecting us. And you'll also notice near the south pole of the moon, a whole bunch of craters right around the south pole. We'll talk about the south pole of the moon in a little bit. Some quick moon facts. Is there an atmosphere? Is there any water? So there really isn't an atmosphere on the moon. We can't live on the moon without a spacesuit. Is there any water? So originally we thought that there was no water on the moon at all, and no water at all. But recently we've made some additional discoveries to change that idea. The moon's tidally locked with the Earth. The moon's roughly about a third as large as the moon. The moon's actually getting a little farther away from us. It gets about 1/4 of an inch further away from us every year. It's about as fast as your fingernails grow. So when T-Rex would look up at the moon, it was probably about twice as big in the sky. Moon day is about 28 Earth days. And the way the math works out, that's about the same as a moon year as well. So a day on the moon's pretty much a year on the moon. The moon has gravity. You have gravity on Earth all the time. There's a gravity everywhere in the universe as well. The moon has a lot less gravity than Earth. So if you weigh 100 pounds on Earth, you only weigh about 17 pounds on the moon, so you could jump a lot higher. So how was the moon formed? So what we think happened with the very, very young Earth, a large object crashed into the young Earth, an object the size of Mars, and that collision, explosion if you will, wound up with two pieces of debris. One then coalesced into the Earth, and the other coalesced into the moon. It wasn't close enough that the Earth's gravity could pull it in, and it wasn't far enough away for it to get away. The Earth's gravity kept it close. So we ended up with two objects. Are there other moons in the solar system? Yes, we've discovered over 200. Mercury and Venus don't have any. Earth has one, obviously. Mars has two small moons. Jupiter has 78. Saturn has 84. Uranus has 27. Neptune has 13. And Pluto has 5. So how did we get to the moon? So President Kennedy challenged the country in just 8 years to put a person on the moon and then bring them back safely. It's a pretty incredible statement considering we'd only flown at high altitude before then. We'd never been in space. So how did we get there? A lot of trial and error. So the first phase were the Ranger missions. All we were trying to do is just crash something into the moon. And you can see most of the time we missed. 3 of the 9 hit the moon, the other 6 missed. We then had the orbiter missions. Orbit the moon, actually took some pictures of Earth from space. The surveyor missions, 5 of 7 worked, just to land gently on the moon and send back pictures. And then human space flight. So the Mercury program, 6 missions. Could we launch and orbit a human into low Earth orbit? And only for a few hours usually. The Gemini missions, astronauts being up there for several days to see if that's feasible. And then the Apollo missions, going to the moon with life support. 6 of these flights wound up landing on the moon with people walking on the moon. So 12 astronauts wound up walking on the moon over those 11 missions. Here's one of my favorite pictures. It's called Earthrise. It was taken by Apollo 8. Apollo 8 was the first mission that went around the moon. They didn't land. So here's the surface of the moon in the foreground, and there's the Earth in the background. So we talked earlier about the phases of the moon. If you think about it, if you're on the moon, you talk about phases of the Earth. So this is a cool picture. If you think about it, you have other than the photographer and the astronauts, everybody in the world is in this picture. So we went to the moon with the rocket. On top of the rocket were 2 vehicles, the command module and the lunar module. The command module is what the astronauts spent most of their time in, and it came back to Earth safely. And the lunar module is what went down to the moon. So what we used is by having these 2 things together, we could use one rocket, and it increases the chance of being successful. And the second manned module, in case something happens to the first, the astronauts would go into the second one to stay alive. And that happened during Apollo 13. So here's our rocket. So the astronauts are up here. And you can see our rocket. It's just mostly fuel. It's a huge rocket. It's longer than the length of a football field. It's taller than the Statue of Liberty. And at launch, it uses about 3,000 gallons of fuel a second. So that's about as swim pool of fuel every second being burned. So basically it's just a huge thing of fire with the astronauts way up top. And up top, here's what it looked like. Here's our lunar module. Here's our command module. This is how we launched. And then after we got out close to the moon, they'd come out and we turn around and connect. The Apollo, when we went to the moon, it's the first time we ever used a computer. These are the first computers to use what we call priority scheduling. So what that is computers before that, they would just do the task in the order they were told. What priority scheduling does is, hey, it's more important to keep the astronauts alive than to turn the TV on, even if we turn the TV on first. And one of the lead engineers, her name was Margaret Hamilton, she called the program software, and that name stuck. This is the first computers to use microchips. The Apollo missions had 6 chips. Each one had 6 transistors in them. That's about 36 transistors. By comparison, your phone has about 40 billion transistors in it. It's a 4 with 10 zeros, and about 1 million times as much memory. So you have a lot more power in your hand than we went to the moon with. Apollo 11 is the first mission to land on the moon. Neil Armstrong and Buzz Aldrin went down to the moon. Michael Collins stayed behind in the command module. Neil Armstrong was the first person on the moon, and Buzz Aldrin was the second. And that happened in July 1969, a little over 50 years ago. And there's the first footprint on the moon. So what's on the surface of the moon? So there are lots of craters from meteors. And if you want to do this in your at home, if you toss a water balloon in the air on your driveway, you can look at the splatter pattern. It's kind of what the moon does. You throw them high or low, different angles, you can see different differences. And you can see the impact of different size and different speeds has on your splatter. You tell your parents it's okay, it's science. Up close, the lunar surface. Luna is the Greek word for the moon. It's made up of rocks and dust. It's called regolith. And regolith is from 2 Greek words meaning stone blanket. And it's full of glass shards and micrometeorites that got all over the astronauts and stuck to the uniforms and pretty much stuck to everything it comes in contact with. We brought back a lot of rocks. So what did we learn? Early moon was molten. The moon had volcanic activity in the past. The moon was bone dry, and that's what we concluded about 50 years ago. We've changed our minds on that. The rocks aren't 100% similar to Earth rocks. By understanding the moon's history, it helps us understand how the solar system was formed. So what did we bring back? Other than the astronauts, life-supporting rocks, we left a bunch of equipment behind, including the diapers the astronauts were using. So they've been on the moon frozen for 50 years now. And here's where the 6 Apollo missions that all landed. You can see they all landed near the equator, and you can see they didn't spend a lot of time on the moon. The longest mission almost spent a day on the moon. So they all landed on the near side of the moon. And that's so we could always stay in radio communication with them, and always near the equator so we get the longest day, so the most time we can talk to them. So what have we learned since then? We've learned a lot from a mission called Lunar Reconnaissance Orbiter, or LRO. It's been orbiting the moon since 2009. It's done a lot of mapping of the moon. And a lot of areas of the moon, especially near the poles, don't ever receive any sunlight. So the Earth kind of wobbles. That's how we get our seasons. The moon doesn't. So in some of the craters near the South Pole, we think some of them haven't seen sunlight for billions of years. And we've recorded some of the coldest temperatures in the solar system there, colder than Pluto. And we're now convinced that some of these areas contain water ice, these cold areas that have been in the shade for billions of years. Okay, so what's the big deal about ice? You might have some in front of you. Well, you think about ice, if we can melt the ice, we could use it as water, help keep astronauts alive. Water is made of what? Hydrogen and oxygen. If I can separate those 2 things, I can use oxygen, help keep astronauts alive. And hydrogen and oxygen are also the ingredients for rocket fuel. I could use that to launch the rocket off the moon, or hopefully heat a base on the moon. Now those things aren't going to happen tomorrow, but it's step 1 that maybe over time, and maybe in your lifetime, we'll have people living on the moon. So like I said, 12 people walked on the moon. No one's been back for 50 years. All of them were American. All of them were men. Is there any plans to go back? Yes, there are. We're going to go back in the next couple of years. And one of the big differences is some of the first astronauts on the next mission to walk on the moon are going to be women. So girls on the moon. One thing about the moon is everything we need to figure out to go to Mars, we can try and test on the moon. We can get to the moon in 4 or 5 days. At its closest, it takes 6 months to get to Mars. So we can have a lot more missions to the moon, and we can try out a lot of things, get a lot of tries at it. And if we can use the water on the moon, it becomes easier to sustain a manned base on the moon, a crewed base, sorry. So we're going to go back to the moon using the Artemis program. In mythology, Artemis is the twin sister of Apollo. The goal was 2024. That's probably very optimistic. It'll probably be 2 or 3 years after that. We're going to go to the South Pole of the moon, where that ice is. And here's what the Orion spacecraft will look like. So think about your bedroom, and think about 4 or 5 of you in there for a few days. We're going to build something called the Gateway. So think of it as similar to the International Space Station. The International Space Station is only about 100, 150 miles above the Earth's surface. The moon's 300,000 miles away from Earth. So this is going to be similar to the International Space Station, only very close to the moon. So you could launch up to the Gateway, stay there for a few days, go down to the moon, come back, go down to the moon, come back, and so on and so forth. And there you can see there's the Orion spacecraft docked to the Gateway. So the Gateway doesn't exist right now. We have to build it up in the next few years. So short term, we're going to go back to space, start building out the Gateway, and people on the moon. You see rovers and a little place to live. Longer term, Gateway becomes even bigger. More and more people on the moon, a pressurized rover that people can drive, surface habitat, and start to see if we can generate surface power off the moon for ourselves.